Hi guys, today we're starting my favorite chapter, chapter 4. It's solving systems equations. It's one of my favorites because students are usually really good at this topic and I think that they're fun to solve. So we're going to be starting with two variables, solving for x and y. Eventually we'll get to three variables and I'll show you a few different ways of doing this. So for our first example, it just wants to know whether the ordered pair is a solution to the system of equations. So to figure out if it's a solution, all you're going to do is check into both equations. If they work in both, then yes, it's a solution. If they don't work into both, then no, it's not a solution. So please try this, hit pause, and see what you get. So for A, it does work. For B, 3 times 1 minus a -1 becomes +1, which is 4. So 4 equals 4. For the second equation, 7 times 1 plus 2 times -1, we get -5, which is 5 equals -5. So that is not true. So this one is no. So that just means if we were to graph A and graph both lines, they would both intersect at they would intersect each other at -3, -5. Or if we solved it algebraically, we would solve x equals -3, y equals -5. There's a few different things that can happen when we're graphing two lines. One is that they're independent. You graph both lines and they intersect at one point. Independent. Graphs intersect at one point. Our solution is x comma y. So that's the most common and the most normal. Look at the second one. What do you notice about the lines? They are parallel. This one is called inconsistent. The lines are parallel. They're never going to intersect. So the answer to this one is no solution. They never intersect, so there's no solution. And 3, I don't know if you can notice here, but these are two arrows on the same line. So it's dependent. The graphs are the same line. This one is the trickiest to write as a solution. The solution for this is x comma whatever our y equals, so maybe 2x plus 5 or whatever it is. So we'll practice that when we get to it. All right, hit pause, go through the lines for example 2 and label them independent, inconsistent, or dependent. All right, so check over your answers. For A, I have independent. For B, dependent. C, inconsistent. And D, dependent. All right, so how to solve these graphically? You probably already know what to do, but we're going to start by graphing both lines. So you may either do the chart method or do the y equals mx plus b and graph by slope and intercept. Most likely, the graphs will intersect. So we want to label the equations. So label the equations. Make sure to label the intersection point. That's the answer. You want to label the equations, use the original, and label the intersection point, xy. If they're parallel, remember it's no solution. If they're same, it's infinite solutions. X comma the y equation. All right, so we're going to solve this one by graphing. The first thing I want to do is get them into y equals mx plus b. So x plus y equals 1. The nice thing about doing this on your surface is that you can change it and do color coding very easy. So I begin at 1. My slope is down 1 over 1, down 1 over 1. Use my ruler. So I have x plus y equals 1 for this graph. We have 2x plus y equals 0. Y equals negative 2x. It begins at 0, down 2, right 1, down 2, right 1, up 2, back 1. Grab my ruler. Make sure that you label your intersection point. So these graphs are intersecting. So the solution is x equals negative 1, y equals 2. If I wanted to check, I could plug it into both, make sure it works. Negative 1 plus 2 is 1, yes. Negative 2 plus 2 is 0, yes. So they both work. Try it too. Get them into y equals mx plus b form, graph them each. So I have y equals negative 2/5 x plus 2. Down to right 5, up to back 5. I'll label this one with the original. 2x plus 5y equals 10. As you see, they have the same slope. So what do we know about two lines with the same slope? They're going to be parallel, very good. Down 2, right 5, up 2, back 5. So we'll make sure we write no solution. We'll label that other line. And lastly, so I have y equals 3/4 x minus 3. As you can see, both of these lines match. So I begin at negative 3. I go up 3, right 4. That's all I can get on the graph. It doesn't matter which one you label with this time because they're both the same. If you want to show them both being the same, you can just put another set of arrows on here. So this is how we write the equation. It's x, comma, the y equation. So y equals 3/4 x minus 3. So infinite solutions, every coordinate that falls on that line. All right, for your assignment, you have 6 of these to graph. They all have an intersection point. Do a quick check to make sure you're right. I put the answers at the bottom of the page. Make sure you're labeling the lines and showing the intersection point. I hope you do an awesome job. And if you need help, never hesitate to ask me. Thank you so much.